let's talk about radicals. And by that, I mean, we're talking about square roots, cube roots, those type of things, and how we deal with them. Of course, we don't use them in everyday life, so this does feel very mathy, let's just say, because they've got funny symbols and so on. But when it comes down to working with these, you'll find it's not so bad. And in this lesson, we're going to really explore the idea of simplifying radicals. All right, first off, doing a square root. Easy enough. What times itself gives me the number inside the square root? And our perfect example, just to start off, is the square root of 36. What times itself gives me 36? And of course, that's 6. 6 times 6, 36. There's my answer. Square root of 36 is 6. Notice here, I have no square root symbol anymore, and that's because I used it up. I was able to evaluate it. It's done. But what if we've got a problem like this? The square root of 40. What times itself gives me 40? And yeah, it's some decimal, but off the top of my head, I don't know what that is. So in this case, we can't evaluate it, but we can simplify it. And again, that's the point of our lesson. Here's how we break it down. We want to make the answer simpler. That's what we're looking to do. So what we explore is this. We look for all the possibilities that multiply to 40. I'm going to write them all out here. 1 times 40, 2 times 20, 4 times 10, 5 times 8. Out of all these multiplication combinations, are there any numbers in this list that I can do the square root of? Well, yes, I can do this square root of 4. And because I can do the square root of 4, I'm going to use the combination 4 times 10 for the square root of 40. I'm actually going to rewrite the square root of 40 as a combination of those two. Square root of 4 times square root of 10. This is how we simplify radicals. We break it down into a part that we can evaluate and a part that I can't evaluate. And that square root of 4 I can do. It's 2. The square root of 10 I don't know off the top of my head again. 2 the square root of 10. That's the simplification of the square root of 40. Let's move on to variables now. How do we deal with those when they're inside a square root? Well, first off, let's work with a variable expression that we can evaluate. And that would be like the square root of x to the 4th. What times itself gives me x to the 4th? X squared times x squared gives me x to the 4th. But how would I actually evaluate this? Let's go over how we deal with this. First off, we like to know this power and then the root as well. It's a square root, so really there's a 2 hanging over here over the radical symbol. And so if I change this variable into an exponential term, it would be x raised to the 4 over 2 power. Notice where I got the numbers from inside the radical. And then if I want to go simplify this exponent, well, what's 4 divided by 2? It's 2. X squared. Therefore, the square root of x to the 4th is x squared. And my answer. I was able to do that. I evaluated it. Now let's actually move on to simplifying a variable expression. The square root of x to the 5th. What times itself gives me x to the 5th? Not something that I can do and get that whole number exponent like the previous problem. But I'm going to look to do the same thing to simplify this. Let me break it down into 2 parts. One part I can evaluate the square root, one part I can't. So kind of borrowing on the information we did before, I'm going to break it down into the square root of x to the 4th times the square root of x to the 1st, or just x. Well, the square root of x to the 4th, I know that. It is x squared. The square root of x, I don't know that. That 1 is actually too small for the root of 2. Notice I can't simplify that fraction at all, 1/2, unlike the way I was able to do this 4 over 2. So because I can't simplify that fraction, it means I can't do this. I can't do that part. But that's okay. That's part of simplifying radicals. It leaves me with the square root of x. And so the simplified form of square root of x to the 5th is x squared square root of x.